working on a MicroPython application and then you have to make a web front end and a mobile app and blah blah blah, it quickly becomes annoying. Micros is a framework developed right here in Hungary, which aims to be a one-stop shop for MicroPython developers seeking to do more than just a simple embedded system. And I've got here Marcel, who is like more or less my neighbor, and we are going to show you a little bit what the system can do. So, hello everyone. This is me today in an unusual format because we are doing a little interview with somebody working on a MicroPython framework called Micros for the ESP32. And here we've got Marcel from Ericsson. And please tell us a bit more about yourself.
Yeah, thank you. I'm Marcel. I have finished my degrees as an electric engineer, but usually I'm working in a microservice world. If I would talk about the professional stuff. But as a sidetrack project, I have started to experiment with MicroPython for a while, and I made a framework that is publicly available and free. And the main intention with that was to combine all the common functionalities into a package that we can put then application logics to it quite easily with a drag and drop functionality kind of, and copying over internet, so the OTA support is there. And I have a quite detailed documentation of how to do that, how to write custom modules and play with it.
So, this is very interesting. We've got a demo object here. Let's talk about that next. This is the demo object which Marcel so kindly brought to our studio. So please show us a bit what the demo object can do.
Of course.
And stay close.
Let me remove the cover just to show the...
It's a magnetic cover here. So
it is just loading again. It's a tiny Pico board containing ESP32, and with some peripheries you can see an E2C display, a trackball, a small buzzer and touch buttons to it. And as you see, we can stress test it. But what you see is an application logic running the screen and handling the peripheries, but the Micros itself is not that, but what is running that. That's the interesting point in it. So it is using cooperative multitasking to able to utilize the CPU cycles as much as possible, and you can implement several functionalities with it. In the current example, you can see just a smart and bit over-engineered remote controller, so we can send commands to other devices which is running that system via press buttons and using hardware interrupt queries. And of course the trackball is for maneuvering in the GUI application, and you can switch in between the pages. These pages are generated automatically from a configuration, so you can add it from a phone. So it has also a client in App Store and Android. I don't know what else should I say about it.
Well, that's a very interesting demonstration. I like the GUI, so I would suggest let's dive a bit more into the technology next. And here we've got the main architectural diagram for the MicroPython based system, which you can incidentally also download from the GitHub repository of the project. Marcel, please explain us more.
Thank you. So what we discussed is application modules, and what's visible for the user at the first hand is that these load modules. The fantasy name is load modules because these are consist of the flash memory and loads dynamically into the system. So these are the meaningful applications that you can write and also plug in the Micros framework with. And in the upper side you can see which functionalities it automatically gives you. Like for example, the configuration management or the network management thingy, to how to bring the system up in access point mode or on station mode. And as well we have task management, because it is not a synchronous application. It uses that, as I mentioned, cooperative multitasking and then scheduling different items seemingly in parallel. And of course, as systems we used to write, we have to have some debug management, right? So if we make faults, we have to know where it is coming from, either in the core system. This part is the core system and these are the application layer in this sense, but it gives quite a good level of debug messages. Next to these and connected to the network functionality, we have NTP synchronization. We can handle requests, and we can have a special and as well custom communication in between these devices that I named intercom, so we can send commands to other devices and receives as well sensor data or whatever we would call that. Of course, due to its ESP32, so it's a microcontroller environment, we have different interrupt queries. It could be an external interrupt on a GPIO, or even a time-based interrupt in a cyclic loop that can wake up a callback that runs the any kind of application logic. But that system is meant to be designed to run and manage these load modules, or in the other way, application modules. But how you can access, call these functions. As I said, we have a client for that, a phone client to control, and the other way is the web server. It can start, so it have a normal web UI that you can control and call commands over. I'm pretty sure that's all. Maybe one more thing. There is a detailed documentation of how to use these modules. You can use pure MicroPython commands in it, so nothing special. You are totally free to play with it. But there are central functionalities in this framework, what you can officially use on your modules without implementing an entire complex logic. And you can use it from the common module. We have a micro IO, this manages the GPIO, so avoids overbooking of the pins and so on, so basic functionalities. And I have also the types module, which it makes possible from the front end to regenerate automatically the elements from the function calls we implement in these load modules.
And what we see here is the development assistant on the desktop for deploying modules. Marcel, the floor is yours.
We can see here two methods of deploying these boards. One is via USB. First, when we buy a new board, that's normally empty, or there is there any demo software maybe on it or not. But the first thing to use Micros is to select a supported board. You can see a list of processors here. All of these are supporting Wi-Fi access because the whole project is in the IoT category, so it's a basic functionality. Then you can choose one of the board you have, and then you can just press deploy with USB. Of course, you have to connect via USB the board and install the software on it. Afterwards, it's way more easier. You have a board you have built, and you can search devices on the local network, and you can select from a list a scanned device, like that Pro controller is the device here, and we can make different operations with it. We can OTA upload, so over the air update is supported. We can just upload the load modules. And even more interestingly, we can start a simulator on the local machine as well. So without any hardware components, you can try out the framework, at least the communication part and the web front-end part. And the last thing is, if you write a code, it could be a simple file, ends with .py, because it's a MicroPython project, and you can just drag and drop it to that field, select also the device, and you can upload it, and that's it.
And next, can you please show us the simulator in action?
We can press the simulator, and it starts. Normally it starts very fast, but now we don't connect to the network with the Wi-Fi because we are on the access point of the ESP32 itself, and the default configuration of the simulator would sync with the network time that it cannot access, but in the meanwhile it already started. We have two interfaces. One we can access with the telnet. You can see here we can log in to the board. We are in the simulator and we can say a simple hello to it and it responds with a custom message, or we can get help because who knows it, what it can do, but it automatically sends out the default operations and as well the load modules and the internal functions in it, and we can call functions basically from that. And the other interface of the program, what is more shiny, I would say, is the web frontend. It is already open. We connect it to the board frontend, but here is the simulator frontend. You can see the node name here and as well the software version, and we can ask system information, we can list the alarms, we can check the clock, we can list the tasks, and as well there is a dashboard feature which automatically parses the application logic, and we can control in the simulator the simulated buttons. So let's say I press on, and in the console we can see what message went out. Just there is a periodic task, so I have to press it again. So with these simple REST calls you can have control over the device.
I know it's the usual influencer dance, but it's necessary. Down here, please subscribe, like, and activate the ring, ding, 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 ding. Because otherwise I'm gonna have to become an a cappella singer or something like that, and that would be really, really bad for the ears of the world. So thank you. And just to show that this is not a fake trick, here we've got the evaluation board connected, and please control it, my friend.
We can step in between pages with the next and previous buttons. We can as well turn it off and automatically start a screensaver, which is Conway's Game of Life, mathematics simulation. It's always good to see. And we can turn it again on, but there is a deeper level of driver for that specific screen, and we can invoke the invert function and as well anything what you wish to export to this format. And that dashboard is automatically created runtime. That's the fun part of it.
Next, we are going to look at the structure of an actual module. And the most important thing is here the name suffix. LM underline means this is a Python module which is intended for the use in the Micros framework. And please tell us a bit more about what this module actually does.
That module imports several common functionalities from the core system, like the micro I/O that handles the inputs and outputs. There is a resolve pin and the pin map search function in it. These are for the function when you don't want to refer by an integer the pin number, but you would like to have a logical name for it, and you can define a lookup table for each type of boards, and you can resolve the integer of the logical name of a pin. That's only for the reason to be able to support multiple types of boards with the same exact load module. There we have a types. I will take some words about it later on at the end of this code, because that will be relevant there. That's a pure MicroPython module, that the machine where we import the pin and the PVM functions, and we have also the uptime here to be able to sleep in millisec, which is also a MicroPython specific sleep function.
One thing which I find interesting, if I see the class, there is no base class or anything. It just is a class and it exposes some functions for the framework. So if
let me correct, because the only reason why we have this class here is to avoid global variables, because that could be costly. So that class is a simple static class. In the hidden background it has a base, but we are not utilizing that. So actually the end of the function, end of the class finishes in the line 14. So these are just contains configuration parameters that will be used by these simple functions later on.
It's very interesting. So please show us more. So basically, if I understand correctly, these functions are what by reflection gets exposed to the phone app or to the web interface, which we saw before. Exactly. So here we have the load, that's probably intended for initialization.
Exactly, these are initializing the output for the...
And then here we've got the actual method such as tap, and this is what was before exposed in the web.
Exactly, so when you press on that, actually it loads, calls the load function from the previous page, but it also caches the instance for the GPIO. So if it's already loaded, it is just giving back the instance of the haptic, which is a PVM control. Makes possible we can set different PVMs on it, and it will result a haptic feedback at the end.
And here we see some more functions like gen and like effect. What I see interesting is here you call these sleep milliseconds. This is for the cooperative multitasking, I assume.
No, these are more stupid than that in this scope. So if you are using cooperative multitasking, you have to await for the event that feeds the main event loop, where in the meanwhile other codes can be executed. So that load module example is simply synchronous code. The core system is an asynchronous code which will embed that synchronous codes into.
Perfect. And then the rest of the module, which of course is available online. Yes, here we've got a dinit method, that's a destructor probably. And here help, what's that for?
There is two important things. One is the pin map, where you can get runtime the exact mapping of the pin. So we name the logical name of the pin is haptic, and that will be resolved by the pin map search and will result as an integer, that is the physical pin on it. So that's for the runtime help message, part of the runtime help message if you would connect it. Then other function is a help message, also for the same reason, to be able to run, list the available functionalities. You can see an interesting thing in a help message. By default, it's a tuple, it's a primitive list that is giving back the function names and optional parameters. But here you can see it's not a simple tuple, because that's internal brackets are the tuple syntax, but we are using the resolve functionality from the types module. And it's a free text, but you can use prefixes with capital letters like button or other types defined in the documentation, and due to that capital letter tagging, you will get automatically the front-end elements as a button or as a slider or as an RGB widget.
So this basically generates the widgets to show on in the front end.
This is the input for the front end element to be able to construct the front end elements, I would say, yes.
This is absolutely amazing. I have to say this is a really amazing piece of kit. And yes, of course, the code is also available online on the GitHub repository. And now, of course, the next question is what it costs. I mean, we see here the board that we use is not particularly expensive, and it's basically an ESP32 based chip. So if you don't want to repeat the actual demo, you can just use something else. But this, of course, is only one part of the equation. Is the red dot visible? So Now, if we look here on GitHub, we see it's under the AGPL. So, for an open source project, you can use it for free. And what would be your plans if somebody wants to use it commercially?
Commercially, I think they would have a support for that from me in general to have a deeper integration into the system and a bit of hints. But normally I would support creating more serious products than just homemade things for it. But I haven't considered that solution yet as a production ready thing. So first of all, I would build up a DIY community who would try this out, have experiment with it, and based on the feedbacks we can judge the things. But of course I have system tests and so many things. I can talk a lot about the software and quality checks, and based on experiments and a few years of usage, it's very stable. So some of the
How many people are in the development team, if I may ask?
Yeah, on the backend side, so the software that runs on the microcontroller, I'm doing that only, so a single person in this sense. But I have a friend who also writes application logic to it, and he knows quite well the system itself. So I'm considering him as well as part of my team. So two of us, and I have one other friend who wrote the front-end applications, or we can say the phone application as a front-end to it.
And with that, we are ready. I have to say this is one of the very few recent Python projects which really managed to impress me. Please visit them on GitHub. Please check out the documentation, and if you've got any questions, leave a comment and I will try to get it answered as fast as possible. Thank you so much.